Looking at this question, it says two competing headache remedies claim to give fast-acting relief. An experiment is performed to compare the mean lengths of time required for bodily absorption of brand A and brand B headache remedies. 12 people are randomly assigned to brand A and given an oral dosage. Another 12 people given brand B. The length of time in minutes for the drug to reach a specified level in the bloodstream was recorded. And here's what we've got for our summary statistics. So let's look at how we would perform a hypothesis test on whether or not there is a difference in these two absorption times. First of all, I'll set up my HO to say mu1 equals mu2. And I don't have an indication from the problem, from this part of the problem, that says whether I think A or B is better. So I will do a two-sided test. I don't simply want to look at my data to make that decision. That's sort of like looking at it after the fact, and it's not intellectually honest. Where mu1 is the average absorption time for brand A, and mu2 is the average absorption time for brand B. It is perfectly acceptable to use these ditto marks. It is not acceptable simply to say mu1 is brand A and mu2 is brand B. I need to talk about what characteristic of brand A and brand B we're looking for. Now, in order to perform a hypothesis test, I need to talk about some conditions. So let's look at the conditions. First of all, it told me the people were randomly assigned. That's different than saying they were randomly selected. So I hope the two groups are independent SRSs. They need to be independent because I'm going to do a two sample problem, and they need to be simple random samples. Next, I need to see if I've got large counts. Well, I don't. Both of my sample sizes are small. I would love to graph them and see what the graph looks like, but since both sample sizes are small, N1 is 12 and N2 is 12, I hope their graphs are reasonably symmetric with no outliers. Because I've got small sample sizes. It's a little tough to see that this says sizes here. And I hope that I haven't sampled too much of the population, but certainly 12 is less than 10%. So certainly there are more than 10%, more than 120 people who could have been given each medicine. And this is the 10% rule. So you know where that came from. So since those conditions are either met or assumed to be met, I will use the two sample T procedures for means. And again, I'm using the T procedures because I don't know the true standard deviation. I've got S1 and S2. So moving into the next part of the problem, I can talk about the formula. And the formula looks like this. T equals x bar 1 minus x bar 2. That's the statistic minus the parameter over the standard error of the estimate, S1 squared over N1 plus S2 squared over N2. Now, I advocate showing the numbers plugged in here, so getting them back from these summary statistics here, I'm going to take all these numbers and plug them into this formula, and so it'll look like this: 20.1 minus 18.9. This second part goes away. That's 0 over 8.7 squared over 12 plus 7.5 squared over 12 square rooted. Now, I do not advocate doing this out the long way. At this point, I would grab my calculator and I would go to SAMP t-test and type in this information. So X bar 1 is 20.1, et cetera, et cetera. Type that in. I'm doing a two-sided test. My calculator asks me if I want to pool. I do not want to pool. So I hit calculate, chicka chicka whir whir, and I get this information. So that's telling me that this formula equals 0.362. I would also include my degrees of freedom. You could either write it like this, or when you draw your curve, there's my t-test statistic that I put on there. It's a two-sided test. You could write t sub 21.5 to indicate that you've got 21.53 degrees of freedom. You do not have to show the work to get that degree of freedom. The formula is complex and unnecessary for us to look at. And of course, I want to write down that my p-value is a whopping 7.21. And so finally, I'll write a conclusion in context, and I'll say, since my p-value is so big, how big is it? P equals 0.721. Include it right there so somebody else could look at that and decide, oh, yeah, that is pretty big. I will fail to reject HO in favor of HA. And so what that means is I don't find that this difference in here with this standard deviation and this relatively small sample size, I don't find that that difference is statistically significant. So that's what I'm going to write on here at the bottom. That is, I do not find a statistically significant difference in absorption times for brand A and brand B. And there's a good, complete two-sample hypothesis test for means.